All right, so we'll get started and talk about OpenAPI and security. My name is Isabelle Mauny. I work for 42Crunch. I'm the field CTO at 42Crunch. And security and OpenAPI might not be two things that you usually associate together, but this is what I'm trying to convince of you for the next 20 minutes. And hopefully you will see you can also benefit of OpenAPI from a security standpoint. But before we do that, let's start with an example of a recent breach that happened to a company you may have heard of called Starbucks. Basically, at a high level, and I really, really encourage you to read the actual write-up on this that you have on the slide right now. What happened here is a hacker basically poked around to find some problems around the APIs, been trying to test many different invalid paths there. Ends up finding some things that work. So it's that's usually the way hackers work. They will start to find some information by poking around, and they start finding some API that they can navigate and find some data in. And also find a way to trick a solution, a security solution that was there in place, which is a web application firewall, whereby they try to basically navigate their way up into the path that leads to some data. So you can see that request here where it says ... So basically what the hacker wants to do is they want to go one level up, then one level up, then one level up, all the way to the root of this to see if then they can actually go down. So they tricked basically the application firewall by putting that dot in the middle of the dots. So ... doesn't work, but ... does work. Some rules somewhere which is probably not properly written, but it allows them to navigate in there. And from there, they start making a lot of calls to go all the way up to that data graph. And they end up doing that. So you see there's a lot of ... in here. So they had to go all the way 7 levels up. But all the way 7 levels up, they ended up into a place that was the root of Microsoft Graph application. And they were able to actually get down into finding a lot of accounts, about 100 million, actually, if they had wanted to. So hopefully this was not exploited because it got reported to Starbucks and they actually fixed it. But that's how they could actually access that data. And what do we learn from this? What we learn from this is the way hackers behave and the way they're going to try to hack your APIs. It basically through trial and error. So they're not going to play by the rules. They're going to, try and understand how your API is working and what it allows them to do by invoking the API with all kind of, different verbs, for example. So even if you say you only support post, they'll try something else and see what happens. What type of answer do they get? Then they will try different resource names. So if this is like, an education site, they'll probably have users and students and teachers. If this is a bank, they have accounts and admin. Probably there's a search. We're not very inventive, actually, when we create APIs. We're usually not very inventive on the names that we use. So there are whole catalogs of things, you can use to try to discover some data you're not supposed to actually find. What else will they try? Well, they'll try different content type values. And, remember CVE. You may not know that CVE by name, but you will certainly remember Equifax and their problems about a couple of years ago, and actually them and many other people. And that whole problem came from being able to overload a content type header value with some basically an expression language and execute that expression language. So try that and see what happens. Inject data, and in API's term, we'll start calling that mass assignment, which is, okay, you're telling me your API is accepting such and such data. Well, I'm going to try to send some more data and see what happens. Maybe I can override some data on the back end from something I'm going to inject in here. For example, something like is admin equals true, and see if that can override something in the backend that says I'm not an admin. Now I can become an admin. And this is kind of a methodology that they use to basically, pull from a thread. So they'll make some calls, get some answers. From those answers, they will find some information, maybe about your backends, about what you have used to implement it, what server you use, etc. And from there, they'll, do and try and make some other calls to find more information, and that's kind of the methodology. And actually, there's this really nice lady who has created a very good video on how this is actually done and teaches you how it's done, and I very much encourage you to watch that. It's very enlightening. We don't have really the time to do this now, but watch that. It's very enlightening about this methodology, right? So that's kind of what hackers do. Now, why are those problems still happening? So why do we allow somebody like at Starbucks or any other large companies that have been breached recently, about 200, 300 of those in the last 18 months? Why is this happening? What we see, at least in our company, is one of the huge problems is security is considered very late in the API life cycles. We tend to just develop all the functionality, do all the work we want to do on making sure the API will basically react and implement the functionality we need for our applications, and security is kind of more an afterthought. When we get to the point in the life cycle, we become like sometimes difficult to put it in place at scale, I would say. And the at scale part is very important, because development has become extremely agile for many different reasons in the last 5-10 years. We're developing and releasing code at a very heavy, very rapid rate compared to, a few years ago, when an application would change every 6 months or every year. Those days are long gone. So it's very difficult for the testing and the security part of the house to actually keep up with this, right? And finally, there's also quite a lot of trust, and maybe too much trust, in the fact that, we only have internal APIs, so that's less of a problem. But the apps which are using our APIs are only internal apps, so we're not really advertising our APIs. They're not used by our internal apps, our mobile apps, and we don't have a developer portal where we expose those. So that's less of a problem. And of course, that is completely wrong, because it's very easy to discover what the API traffic is from a mobile app, from a web app. It's very easy to reverse engineer, I would say. And of course, we also trust in internal users. So if my application is only internal, my APIs are internal, and they're used by internal users only, that's probably less of a risk than if it's used by external people. And interestingly, most of the problems actually come from inside. They're not so much coming from outside in many companies. So one of the recommendations here is really just put everybody on the same level here and consider all APIs and all apps and everything as being insecure and untrusted. And then you will have, a better chance of getting a good security. But now let's get to OpenAPI. So how can OpenAPI help with all this, with security, right? Well, the first thing is, one of the great thing about OpenAPI, what it allows us to do, is to very thoroughly define what the API does. I can, through OpenAPI, describe every piece of data, every header, every path parameter, every query parameter, all my requests, all my responses, describe very thoroughly what those requests and responses are, put patterns on them, put constraints on them. So the standard is there to allow me to do that, right? So it's very interesting to be able to do that from a security standpoint. And then we'll talk about this when we talk about the positive security model, because it allows me to really know what my traffic is going to be. Traditionally, in applications, we've not really been able to describe what an application does. We didn't have any universal language like OpenAPI is to describe, hey, this is my application, this is what it does, that's how you invoke it, and that's how I'm going to answer to you. We never had that, but now we do, right? So really, the first thing that you want to know is like, how is this API really hardened? And if you want to do that, you can go to this website called APIsecure.io and there assess how a specification, is it really hardened and has all the information it could have? And that's the type of information you're going to get. What you will see is, oh, for example, my security definitions are really poor, right? I'm missing a lot of information there. We don't even know what your security looks like. My parameters are not well defined. It is all about being able to define the constraints. So what this tool will do for you is just give you this information about how hardened and how complete is your API definition. This is something that we do at 42Crunch. And what I wanted to share with you is what we see and people discover from this and how they benefit from that. So why this matters, right? The first thing we're going to look at is security, right? And for example, we're going to evaluate, what do you use? Do you use an API key? Do you use OAuth, right? And what are the implications of doing that? So how sensitive is your API? What would happen if this API key would be lost? Because one of the key differences between using API keys and OAuth is one is much more usually static than the other, right? Typically, the key thing is I'm generating an API key on a site from a developer portal, for example. This will be valid for weeks or months, even more maybe. And therefore, the risk of this being lost, being hard-coded, being somewhere in GitHub, being in a log, or being stolen and replayed is much higher because of the sheer time this API key is actually valid than if I'm using something like OAuth, where by definition, I'm creating something which is where the lifetime of what I'm creating, of the token I'm creating, is much shorter. It could be seconds, or it could be just minutes. So if somebody steals it, then the window of attack that they have is much smaller than if they get an API key that is valid for weeks. It's kind of logical, right? Then what is this key giving you access to? All of that is also critical. What is the scope of this? So all of this we can analyze from the OpenAPI file. And as a parenthesis, by the way, along this, if you're going to adopt OAuth, remember that authorization code is really the only grant type you want to use in probably 90% or more of cases, right? So unless you have a very special case, this is now the recommended way of using OAuth. I'm just opening this parenthesis at the opportunity to actually say that, just spread the word. So that's the security aspect. So we're going to analyze, how your API is actually secured and give you some recommendation out of that. But more importantly, and this is what we see everywhere, the great problem about APIs is what they're allowing me to do is to expose data to the outside world. I know this is exactly what we want to do, right? So it's not a problem, Isabelle. It's what we want an API to do. But in the end, it is a problem because it is exposing my backend systems and my backend data to third-party consumers, to an outside of my data center, if you want, right? So controlling that data, controlling the data coming in and controlling the data coming out is very critical. And this matters in a number of known type of issues now. So we have this new OWASP top 10 for API security with a number of problems in there which are related now in terms of overflow protection, for example. So API 4, which is about resources and rate limiting and overflows, unique constraints about that. So if I'm looking at this, the schema on the right with an email, with the password, the name, can I put in name a string which has 3 million characters, for example? If somebody does that, what will happen? Well, it's going to fail somewhere, most likely, but where do you enforce that? If somebody puts something which is not an email in the format, what happens, right? Where do we enforce that? So we need constraints. And when we work with customer, we see very often that the schemas and the data is not constrained in OpenAPI. But OpenAPI allows you to define those constraints. So array sizes, patterns, minimum length, maximum length, and all of that, if you enforce it, as we will see, will protect you from overflows, will protect you from injections, will protect you from this mass assignment I was talking about. So all of this is good for what maybe is the oldest problem in security, which is input-output validation. So we have to be very careful here about what we do in terms of the data flowing in and out. So now you know the data. So this is something I wanted to show because I'm seeing this again everywhere. Like in OpenAPI, we see very often documentation, a description saying this is a UID, but there is no definition of that in the spec. Or this is the value for that can be checking or savings. So instead of writing it in the description, what we want to do is putting it as constraints. So it is a UID, which means it has a fixed size, a max length, a min length. It has a pattern. If it's only checking or savings, then that's an enum that only says checking and savings, which means when something comes in and it doesn't matches that, we will be able to validate that and we'll be able to reject that request or that response because it doesn't match those constraints, right? That's a key thing we can do. Other thing is describing all the interactions. So I see that also very often simply because I think from a validation perspective, if you specify a response, just saying 200 OK is enough to make it valid from a specification point of view. But of course, that is not representative of your API. So your API will fail despite all your efforts, even, it's just somebody sending you a wrong token. It should at least send the 401 or 403. So we need more responses in there. And yes, they return data too. So you have to put a schema attached to that information. So it is very important in there from a security standpoint that you put and define very thoroughly all the data. And if you, and all the type of responses, yeah. So for 2.9, if there is rate limiting, 401, if there is no security defined, etc., etc. So all of these we need to document. And also very importantly, it's not only about requests. So input validation is a critical thing in security, but so is output validation. And this is extremely critical in APIs. The reason is we tend to expose way too much data in our responses. And basically, we tend to do that simply because it's easier. and we do that because we expect the client to just say, oh, if they only need 3 fields out of the 300 I'm sending back, that's okay, right? But no, really, you should just send back whatever is required. So properly specifying those schemas on the response will also allow you to validate that the responses you're sending back are the ones you actually want to send back. So you're not leaking some data you don't want to leak, and you don't leak some exceptions because somebody sent you some bad data that you don't know how to handle. So it is also very critical you use OpenAPI to do this validation, right? So take ownership of your schemas. We're here in the previous session, also from GitHub on this. This is really critical, having the proper schemas defined in there. Now, once you have done that, so at the end of that development phase, I would say, we'll have a great OpenAPI file that has been hardened thanks to the tools that allow me to understand what I have to add in there. And now a lot of good things come out of this. The first thing is testing. So again, I'm working with a lot of customers that have 10, 50, 100, thousands of APIs. There is no way your security teams are going to create manually security tests across all of these at speed and at scale. It just doesn't work. But hopefully, thanks to the OpenAPI base, we now just have something that says, hey, this is what my API must do. That's the way it has to work. So we can do all kind of automated testing consuming the OpenAPI file, such as fuzzing data. So I'm going to send you some integers when you're expecting some strings, and I'm going to enumerate some IDs to see if you're sensitive to IDOR, like being able to access resources you're not supposed to access to. Test that if I'm sending you some bad tokens, you're actually going to reject them properly, or access resources that I'm not allowed to, you're going to reject that properly. Validate this navigation we talked about with Starbucks. So I should not be able to go around and poke and do whatever I want on path. All of this should be rejected. So there's a great guide from the OWASP on actually how to do that. But more importantly, there are now a lot of tools that allow you to do this automatically. So OWASP Zap is one open source from the OWASP community to actually do that. That has OpenAPI support, allows you to generate and fuzz an API automatically, consuming the OpenAPI definition. Burp, which is another tool from Forstrigger, is actually more used by maybe pen testers, but I see a lot of customers doing that as well. So also has an OpenAPI module. Yelp recently has open sourced a tool that allows you to do IDOR discovery through OpenAPI. So they will automatically consume a Swagger and generate IDOR testing to see if you're sensitive to this IDOR type of problems. Tinfoil, so paying solutions like Tinfoil that has an API scanner, also consumes OpenAPI. And ourselves at All42Crunch has a set of tools to actually making sure that the implementation of your API actually aligns with the contract that you have mentioned. And it will do that by doing all kind of automated tests, sending all kind of bad data, and see how your API is actually reacting. And we can do this as soon as we have an OpenAPI file in place. And of course, you have all the traditional testing tools are consuming traditionally OpenAPI for more like functional testing, like Postman, Insomnia, Stoplight, and SmartBear, and others. Okay, so all of this automation is very critical from a security standpoint. That's going to give you that scalability from OpenAPI as an added benefit on top of what you already have as traditional functional testing, I would say. And from there, we can even protect our APIs. So this is something which is rather new. We started this about 2 or 3 years ago. There are more companies actually following us now on switching from what is known as a negative security model, which is basically something where you say, well, everybody can come in. We are going to accept all the requests, but we're going to look at those requests and see if there is something suspicious we recognize there. And if we do, then then we will block that. And this is very much threat-centric. So it's all based on documenting those threats and recognizing those threats. And there is the opposite of that is a positive security model where we basically lock everything by default. And we only open to what is approved traffic. So it's more trust-centric. And traditionally, positive security model has always been seen as being more powerful because it has stricter access control. You limit much more the false positive, but it's not easy to do. And it's not easy to do because we traditionally didn't have a way to describe, again, what that flow will be, right? And one of the critical aspects of a positive security model is in a negative security model, until you have that signature for the bad stuff put inside your roles, right? You don't recognize this new bad stuff. Now, think of it, if this helps you, it's like having an antivirus. Until you have an antivirus signature in the database of, the new signature of the virus in the database, you're not going to recognize that virus because the system doesn't know about it, right? So it's much more powerful to have a system that just concentrates on what you want to accept as opposed to what you want to reject, right? And if you have a positive model, then you will block the things which are unknown because you don't really care about other stuff. You care about your traffic and allowing your traffic. And as you can imagine, OpenAPI is great for that because we do have like the perfect positive model that can be based from OpenAPI. We know everything about the interactions, all the operations, all the verbs, all the data, parameters. So if we specify this properly and we put all those constraints that we're talking about at the beginning, then now we have something that really just accepts what we want and will reject everything else. So OpenAPI is opening a very interesting door here and window opportunity from a security standpoint to do things differently than from we've been doing in AppSec for the past basically 20 years. So we're working on that. So is Akamai and F5, and I'm sure maybe others will copy us on this and start taking advantage of this functionality. So as a conclusion, I hope, what I would like to make sure you understand is OpenAPI is great. You've heard about it from a design perspective. You've heard it, of course, you're using it for documentation. But now you have this opportunity at every stage of the lifecycle of the API to also leverage that for security. And the great advantage of doing that is also that OpenAPI files are traditionally done, of course, by the development. So we can start with security much earlier than we have before, which is, as any type of problems that we discover in the code, the earlier we discover problems in the code, the less expensive it's going to be to fix, right? So if we can find all those potential vulnerabilities in our APIs as early as development phase, that's a great benefit for everyone, including a cost benefit when we are going to deploy this in production later. So with this, thank you very much for your time. I hope this was useful, and please don't hesitate to ping us and ask questions and contact me after this if you have any specific questions about this. Thank you very much.